I think it was important to that they had some prior knowledge with what coding actually is. So they did a lot of work in Scratch. They started out with the tutorials, and then they created their own programs through Scratch, like their own games, just so that they had an idea of what's expected of it, like why we code in the real world, right? And then we examined, like, throughout the year. This is kind of ongoing, but I think it was important for because I think this is important to say because we dealt with a new coding program that the kids weren't used to. The kids studied, like, where is coding used real life, and they realized that, oh, it's used in their apps that they have on their phones, and it's used to gear advertisements towards them for when they're on social media. So they understood the importance of it, right? I think that was really important. It helped them take the assignment seriously. And the other, I think, just pragmatically, what was really important for them is we gave them some syntax, like what it means when like something was in green or something was in red, and what do the quotation marks mean, and how do you use that. And then they were able, like, on a separate tab, to have that syntax ready for them, so that they knew, like, what to look for. And they were given some basics, right? So that they didn't have to kind of try and figure all that stuff out while they were trying to actually solve the problem, right? It was all those codes were there for them. We were dealing with the very complex how to solve algebraic expressions. So we started out really, really slow because it got really complex fast, and this was like one of our harder units for them. So it was like, we started out with questions like 3x equals 6. And they knew that, okay, well, 3 times 2 is 6. So that, like, why are you giving us these kinds of questions, Mrs. Stranges? But what they didn't realize is the process that you used, because they just knew that fact automatically, that there was a process used to solve more complex questions. So when they realized that you could do the question by dividing 3 divided by 3, and then 6 divided by 3, and then that they would use that concept of what you do to one side, you do to the other, when they got, like, X on both sides, and they had to get rid of one of the X's. So all of that, I think, like, that was really important, to start really simple with questions they knew how to do, but they weren't familiar with the process it was just like they weren't at that derived fact stage. They just knew it, right? So I think then when they had that process of what steps do we follow to solve algebraic expressions, when it got more complex, they were more familiar with using that process, right, to help them solve the complex problems. And then the other thing we did is, like, some of them could see, like, when X was on both sides, that they had to like, it was like one less or whatever from one side to get to the other side, but some of them didn't get that, so they needed the box method. And I thought that, from Math Up, teaching them that as opposed to, like, the number line, was a little bit more confusing for them. But once they learned the box method, that they could draw, like, if it was 15x on one side and whatever 13x on the other side, that they could draw all those x's and cross them out, and then they realized what number to put beside X. That was helpful for them. They stuck with that strategy.